Okay, so I'm looking for the lattice points on graphs. So in order to figure out if there's a left-right shift. So like if you go back up, this is in what, section 3, I know, section 1 out of the textbook, okay? You see that lattice point there, right? That, to me, that's right on the midline. So that tells me I want to use a sine graph, and there's no left-right shift because it's right on that, right on the midline, right on the y-axis. So I know this is a sine graph that's been shifted down 4, and it's got the period of, oh, I don't know, what is it? The period of 2. So let me do a couple of these, okay? So I'm going to go with the sine graph. I see a midline of -4, y equals -4, and it said sine. I see an amplitude of 3. So 3 sine. I know there's no left-right shift because it's right on the y-axis. And I see there's a period of 2 because it takes 2 units to repeat. So 2 pi divided by 2 is pi. So this is going to be pi x. And there's no left-right shift. So there, that graph should work. Same here. See how that's right on the lattice? That's right there. Here, I'm seeing a lattice point right here. It's not on the midline, right? Well, I guess it is kind of. I mean, maybe we could get away and use a sine graph, see the way it's on the midline. I guess that's pretty darn close. I clearly see that these are lattice points. Okay, this is questionable to me. I think I can get away with it, but I don't know for sure. But this is pretty clear. So this tells me this is I'm going to try a cosine graph. Again, it's on the y-axis because we know normally when cosine of 0 is 1, right? Think about the unit circle. And so I see it's right there. There's no left-right shift. So that would be what? 3 cosine, let's see, what's the period of 4 pi? So 4 pi, let's see, 2 pi divided by 4 pi is 1/2. So I'll say cosine of 1/2 x plus 1 because it's shifted up 1. Okay, so you get that idea. I don't think you're having trouble with that. Let's come down to where there's a left-right shift. So then I'm down here. So this is on page 410, okay, number 17. Now I see the midline of the x-axis, and I see there's a nice lattice point right there on the midline of 1, -1. So I think this is a sine graph that shifted left 1. I mean, I could go with a cosine, and probably that is at 1.5, but I don't know that for sure. So I think that's a guess. This is definitely not a guess. So you look for those lattice points, and what's the amplitude? 4. And the period is what? It takes, it goes from -1, I can't see that. I do see this. It goes from -11 to -1, so that's a period of 10. So 2 pi divided by 10 is going to be pi over 5. So I'm going to say, let's see, what am I going to say? I'm going to say 4 sine of pi over 5 times x plus 1, because it's shifted left 1. And of course, there's no, the midline is the x-axis, so there's no up-down shift. Here, again, see that's a sine graph. Of course, it's an even odd exercise. They do the same thing. Okay, so that would be a similar kind of thing. It would look a little different period probably. Let's find something that's a cosine graph. So you see like number 19, do you see how, again, that's on the x-axis. To me, the midline's on the x-axis because it's 1 below to 1 above. But I also see a nice lattice point right there. So see how it's not on the midline, it's kind of halfway between. So I would go with a cosine graph that's been shifted left 2. I mean, I could go with a cosine graph that's shifted right 3 and just make the leading coefficient negative, meaning it's been reflected around the x-axis, but I avoid negatives if I can. That's just me. So y equals the amplitude of 1. I said cosine. I know the period is, what's the period? It's going from -12 up to -2. That's a distance of 10. So 2 pi over 10 is pi over 5, right? So pi, yeah. Yeah. And then it's been shifted left 2, so x plus 2, and then it's not shifted left or right. And that's that graph. So does that help? Again, there's a shift left 2, or you could say, should say right 4, both are right. You could say right 1. Let's try, pretend you're doing this. We could say that's an amplitude of 2, right shift of 1, but then we know if I go with that point, it's been reflected around the x-axis. So an amplitude of 2, so -2 cosine of, let's see, what's the period? 6. So pi over 3 times x minus 1, because I've said it's been shifted right 1, and then no up down shift because it's on the midline. So that equation works. Also, this equation works. I could say 2 cosine pi over 3 times x plus 2, because if we would go with that lattice point, it's been shifted left 2. Let's see. So see, they're all right answers. We could throw all these in Desmos and we would see one graph. Okay, so that's how, look for those lattice points. That's the way you do this.